gateway is responsible for response to the ARP request. So in GLBP also the virtual IP address and MAC address are generated. So once we can configure virtual IP means the virtual MAC address can be generated automatically. So AVG, active virtual gateway, responds to the ARP request and load balances the MAC replies. So we can see that. So GLBP, gateway load balancing protocol, can be created by Cisco in 2005. So here hello time is every 3 seconds and hold on time is 10 seconds. It is a Cisco proprietary. That means the GLBP protocol supports only in the Cisco device. So the multicast address for GLBP is 224.0.0.102. So all the GLBP router can communicate through multicast address. So that is 224.0.0.102, and GLBP is an UDP protocol and its port number is 3222. So by default preemption is disabled. So I already told you HSRP and GLBP, so both protocol the preemption is disabled by default, but in VRRP the preemption is enabled by default. Okay, so this is an example topology for GLBP. So there is a two default gateways are there to reach the ISP. So the IP for R2 router physical interface is 192.168.100.1 and R3 router physical interface is 192.168.100.2. and PC1 the IP address is 192.168.100.3 and PC2 the IP address is 192.168.100.4. so the virtual IP here I can assign as 192.168.100.254. so this virtual IP address can be assigned as a default gateway for PC1 and PC2. so here I can configure GLBP. so we can go to that interface. So in R2 router interface fast Ethernet 0/0, I can go to that interface and then I will configure GLBP. Here I will given the group number. So the group number range is 1 to 255. So in that we have to give any number, but if you are giving 200 means all the router should have the same group number. So here I will given 200. Next we can given the IP keyword. Next we can given the virtual IP address, that is 192.168.100.254. next in GLBP 200 I will assign the priority value. So the priority value here I will assign 150. next go to the R3 router and GLBP and we can given the same group number and IP. next virtual IP address. next GLBP 200 and priority value I will given 100. so in R2 router and R3 router I will assign the priority value. By default I already told you the priority value is 100. so if it is 100 means the which IP address of that physical interface is highest, that router can goes as an add to virtual gateway. so here I will given manually. so the priority value is 150 for R2 and priority value is 100 for R3. so which priority value is highest? 150. now this R2 router can elected as an active virtual gateway and R3 router is an AVF, active virtual forwarder. so R2 router can act as an active virtual gateway and also active virtual forwarder, but R3 router only elected as an active virtual forwarder. so both routers the traffic can be passed through. so load balance the traffic, ARP request, sorry not ARP request, load balance the traffic. so active virtual gateway is responsible for ARP request. for an example, so PC1 and PC2. so PC1 can request, and here when compared to HSRP and VRRP, in GLBP it can create unique MAC address for every active virtual forwarder. Here two routers are there, R2 and R3. so it will create two virtual MAC address. so it can be create the two virtual MAC address, then R2 router and R3 router can learn the two virtual MAC address through hello packets. so if PC1 can send the ARP request means, so which router is an active virtual gateway? R2. so R2 only responsible to R2 router only responds to the ARP request. so it can respond to PC1, the response to the PC1. so the it will ask the virtual IP, this is a default gateway, so what is the MAC address for this default gateway? so R2 router it can sense the MAC address. For an example, in auto router the MAC address should be 000.111.1111. So in R3 router, so the MAC address is 000.222.222. For an example, this is a virtual MAC address for R2 and R3. It can be automatically generated. It's an example. Okay, so R2 router and R3 router can learn this virtual MAC address. Both virtual MAC address can learn R2 and R3 through hollow packets. Now this R2 router is an AVG as well as AVF, and R3 router only AVF. By default, the load balancing is round robin. That means first the PC1 can request the ARP, so the packet can comes to switch and it goes to the AVG router, that is active virtual gateway. It responds to the ARP request and it can sense the MAC address as 00.111.111, that is R2 virtual MAC address. Now the PC2 again it can sense the ARP request for default gateway 192.168.100.254. So now the R2 router can respond to the ARP request. It can send the virtual MAC address as R3 virtual MAC address, that is 000.222.222. Now the first PC can communicate to ISP through R2 router to reach the ISP, and second PC can communicate to ISP through R3 router. So now it can equally load balance the traffic. By default, the load balancing is round robin. Round robin means if it is 4 PCs are there means, so the first PC can request ARP means AVG responds to is virtual MAC address of R2 router. If second PC can request ARP request means the AVG router can respond virtual MAC address of R3 router. Next, the third PC request means it can reply to R2 router virtual MAC. Fourth PC means it can respond to the ARP request and it can sense the virtual MAC address for R3. So it can equally load balance. So next one is a round robin is a default load balancing method, and another value is weighted. So weighting is, for an example, I will configure weighted is 50 for R2 router and 100 is 100 for R3 means, so 3 PCs are there means 1 PC can communicate through R2 router and 2 PC can be communicate to R3 router, because 50 weighted is R2 and 100 is R3, so 1:2. So 1 PC can communicate to R2 and R3 is twice, 2 PC can communicate because 50 is 1 and 100 is twice. So depends upon the weight, the traffic can be goes. So GLBP 200 preemption. So preemption as usual. So if AVG router can goes down means, so the R3 router takes place as an AVG and it can communicate. So this AVG router can goes down means the AVF router can takes place AVG and it can come. So PC1 and PC2 can communicate through AVG router, active virtual forwarder. So the R2 router MAC address is 000.111. So now R3 router is responsible to take this virtual MAC address and this virtual MAC address. So once the PC can send ARP request means it will send the virtual MAC addresses, this virtual MAC address 000.111.111, and PC2 it can send this virtual MAC address 000.222.222. So even though this R2 router goes down, it will send this R2 virtual MAC address and it will communicate through only R3 router. So thank you. So in next video tutorial I can explain the how to configure HSRP, VRRP and GLBP. So thank you for watching my videos. For further updates, subscribe my channel.